Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video, part 1 of Fred's left bicep, we're going to start assembling the upper arm. This is actually not a real difficult build. We've got a number of parts to assemble together. Some of the things you want to be aware of is this thread can be a little bit funny if you haven't got it free. The servo does drive this screw and you do want it to be reasonably free. As you can see, this one rotates reasonably easy, and that's what you want. So this part, the block, fits into these holes and it will rotate as well. It doesn't rotate much in operation, but there is a little bit of a rotation, so it's best to have it so it is centered. Alright, let's start putting it together. And I will need to set up the 3D pen so I can weld those joints together. Now, one of the parts that are going to become more interesting to put together a little bit later is this joint. So this piece actually attaches, and I've still got a few dags on it to clean off. This attaches to the forearm and is operated, well, it's got a gear on it that operates this little sprocket or gear. That mounts over one of these holes. There's a pot through it. This helps hold it in place. And again, you want that so that it will turn freely. And we will be mounting a pot into that as we go into the project further. Now, if you have a close look at the design of this part, you'll note there's like a V at the top on both, and this is designed to be printed like this. I've seen some people try and modify the design to remove that V. Look, the V doesn't impede its operation, but it does make the printing of it much easier. If you don't have that V there, it will tend to sag as it's printing, and then you're going to have to drill it out, and that's removing material. The more material you have to remove post printing is the weaker the part. So you leave the V there, it doesn't cause a problem. When we come time to actually install the pot, we will work out the range of this part, and we will find the center of that travel, the center of the pot, work out where the gear lines up best, and then once it's all in place, we'll mark the outside here and on the gear so that we know when we're reassembling again at a later date. Alright, so let's set up for welding. Well, that's fine, I just accidentally ejected the filament that I just loaded. Filament's got a lot of moisture in it. it's easy to tell when the filament in the 3D pen's got a lot of moisture. It tends to continue extruding for a bit afterwards as the moisture pushes the filament out the nozzle. I do like the look of the transparent filament when it's finished printing. It is a pain to weld with. Everything's clear, so it's hard to see where the joints start and stop. A little bit concerned about some of the printing on this. It's almost like it was under extruding while it was printing. I might give it a touch up in some of those spots. Okay, so this has got a little bit of the under extrusion in it around the same areas as the other piece did. This is printed with a lot of shells, pretty much. I think I've got 20 or 30 shells on this, and the idea behind that is to try and give it more strength. You get a lot more strength out of an increase in shells than you do out of infill. Of course, if you're doing 100%, then it's nearly all shells anyway. Okay, so that's those two parts done. Might give it a bit of a touch up when they cool down with the file, just to make sure they're smooth. This one's cool anyway. Okay, so this part's a brace. It does increase the strength sideways by quite a lot. At the top you'll see there's a slotted hole. That's for the screw that goes into the bicep rotator, and that'll help hold it all together. With the covers for the arms, this one, yeah. There's some slots in here. These little tags here will actually clip in like so. And this is the wrong side. Okay, so what we should probably do is, we know that's a matched pair, we know where that one fits. We should probably weld in our bracing, and the bracing on the other parts are on the other side. We should weld those ones in as well, and we can start welding together these bits of framework or cover to give them their strength. So let's do that. Downside of using a transparent filament when you're welding is it's hard to see what you've welded. These bits can be somewhat difficult to weld together because of the odd shape. It is still very weak because it's only just really held in this part here, and you can see there's a bit of a seam still. We're going to push it together. I used the desk to hold this side flush while I tack welded here, and I used the clamp to hold these parallel. So let's see if I can get this other side reasonably close to right as I weld that together. Pull together nicely. This is out a little bit further. I was having trouble pushing it together. Alright, so that's not too bad. I could weld the outside. It will give it more strength if I do so. It's actually got a fair bit of rigidity to it now. It will make it stronger if I weld the outside. I might leave it for now. If it becomes an issue, I'll weld it later. That print didn't do very well. Just in here, you see that that's come out more of an angle like so, and like that. I could probably fit that with a bit of heat. I'll fix that with some heat. This is a hot air rework tool used for soldering normally. I've turned the temperature down on it to 200 degrees C, which is ideal for doing this. So what I can do is I can heat up the plastic. I don't want to go too far. That should fit a lot better once I get it all lined up and in place again. Okay, so the only problem left is just in here. And I found this with the very first versions that I made, is it's almost like this cut is reversed to what it should be. So I'm going to mark that, and I will cut it to match what I need, because I can't get that to go in any other way, and I don't want to break it, not having spent all this time welding it up. Same change to this one. I will have to make the same change. Although the print on this part is straighter, this is going to interfere. Have the spacer fits into here. This one here. These ones right here. This one's a pain to weld up, but it's well worth doing. Do it the hard way. Series of tags. Put a bolt through to hold it in place and act as the pivot. Like so. This bolt's a little bit too long, I've got to trim it back, and I'm going to use an eye lock so that it doesn't come undone. I also might give it a little bit of a clean up to allow it to bend a bit more. That's less than 90 degrees at a little bit. This gear then connects to a pot that is mounted through the other side here, which is why I haven't glued any of these parts together yet. That then meshes in with the gear so that as, try that again, as the elbow bends, the gears rotate. And that gives us our feedback on the pot. That'll do for this video. In the next video we will attach this to the shoulder. So this is the left one, so we'll attach this to the shoulder. We probably won't do the servo just yet. We've actually got to do the forearm first before we can attach the servo to it. Once we've done the forearm, then we can attach the servo to it. I may look for, I did find some files online at one stage for a back cover, so I'll try and find those files again. I'll print those out and put the back cover on as well. That just stops fingers from getting in here. Surprising how strong those 805 BB motors are. If you like these videos, don't forget to click on subscribe, like, ring that notification bell. I have a Discord server. You may like to join that and join other like individual members in helping to build our robot and improve on it. I also have a Patreon account if you'd like to support the development of these videos. You can join my VIPs, Go Lucky and Lorenz Burger, and also my other Patreon, Elmerels45. And we'll see you in the next video.